Hello everyone, I hope you had a good lunch break. We're starting with the next session, and before I introduce our next speaker, I want to hint that please hold on to your questions until after the talk. We'll pass through the mic. And also for the remote viewers, please just post the messages, your questions on Slack, and we'll read it in the end. Right. Yeah, it's a great pleasure for me to welcome Alexander Blass as our next speaker. Alexander is head of operations at NEURA Robotics, and he's passionate about innovation and process optimization. He studied mechanical engineering, followed by a degree in aeronautics and astronautics. Later, during his PhD, he conducted research on turbulences and gained deep insights into complex systems. As head of operations at NEURA, he's responsible to strike the balance between turbulent dynamics and structured development, always having an eye out on efficient processes and advancing innovation. Through the combination of agile methods and established structures, he coined the term hybrid agility. And he's always motivated to improve efficiency and flexibility of companies to meet the challenges in today's world of business. Yeah, I'm looking forward to your talk, Alexander, and please help me welcome him.
Yes, thank you very much. Hello, everyone. Welcome to this talk, where I'll try to introduce a bit our company and also especially what a cognitive robot is. But I actually want to rechange the name of this presentation a bit, because at the end, many technology inventions over the last years and also hundreds of years were about time. So maybe about time is a better word for this. And I'm actually not kidding, because I can't see the time very well, so I might be here for 5 hours at some point. You have to tell me that it gets too boring. Okay, but let's start with an example everyone knows. At least for me, the smartphone is something that saves a lot of time. Last week, I didn't have to fly all the way to US to take a meeting. I could just do it on my bathroom if I wish. But at the same time, I also find myself always spending a lot of time I should not on the phone. So this fight between effective time and maybe ineffective time always comes with these things. And if I bring a second example that you might all know about the Mars, about finding technology and improving technology to go there, is something where I personally would say maybe flying there 9 months, being there for at least 2 years to even get the time window to come back, and then another 9 months. So a good 3 years for me would be a waste of time, would be something running away from the planet, just because maybe there's some problems and maybe we find a better planet for ourselves. But there's many also problems on Earth we still want to tackle, and running away from the planet or running away from reality, these all might be similar things, might be not. And so there's different ways of us going away from problems with technology, and where that leads to us, we can have a long discussion about this, and this should not be the point of today, but I just want to set this mindset, which is, it's all about time at some point. And we also, of course, want to start there, but for us it's very important to find solutions for problems here on Earth. Yeah? So our slogan is "We serve humanity," and that should be with robotics that are able to serve humanity, that are able to assist the human to do things. And for example, for me, I don't find it too problematic not to be able to go to Mars, but I find it very problematic if every day I have to bring out the trash, because otherwise other problems appear with my better half at home. And this is an example we want to tackle. Want to find robotics that helps us anywhere and any time. So everywhere should be an option for a robot to help, and anybody should be able to use such a robot. We have, you all know industrial robotics as an example, where someone needs to be coding for weeks to make this happen, but 99.something% of the humanity are not robot experts. So we need to find a way that everyone finds their own approach to teach a robot what it needs to do. And this is what we want to do with our products. And I'll start with a small video, what we do.
We are here to create the future. A good future, where our technologies assist humans.
My great vision is making robots being an accessory for every human, in every home, in everyday's lives.
Are you ready?
Are you?
All the last big things, they were actually created by a need.
Our aim is to bring our technology together with their solutions to create even better solutions for mankind.
The goal of NEURA is what a company brings to the world, the impact. Being more like a technology provider, platform provider for every company in the world one day. Just giving the next step to advance humanity, that's, I think, one of the biggest goals.
And so I used the word cognitive robot a moment ago, and many of you might not know what a cognitive robot is. And so let me explain to you why we as NEURA call this a new era of cognitive robotics. We have robots in automation since very long time. I think about 70 years ago at Ford was the first multi-axis industrial robot, which did many things great, and also today industrial robots do many things very well and have their purpose for sure. And then the next step towards collaborative robotics, where 2005 Universal Robots set the first step, and until now is the market lead, I would say, in this. This was the step, although it's called collaborative robot. It was about, of course, getting the robot closer to the human, but still these robots need either a fence or some other safety system around it. But what collaborative robots did very well is the usability, so it's much easier to use, to teach such a robot. And this is the reason why also many of these are on the market, and always I open the news, I see some other company has some new cobot which is great in something. They all have something in common. They're not really helpful to really assist a human. And why is that? Because they are not able to do some task autonomously. I always have to say, do exactly this, do exactly that, and then they will do that very well. But if I have to tell in detail what I need, and very often I can just solve it myself. So we need a robot that is able to completely understand the task I give to him, and then find a solution by themselves. For that, the robot needs to be able to understand what is a human, and not just, hey, there's some random object, or as the cobots nowadays do, the moment they hit something, oh, this could be a human, so I need to be as slow that I don't hit something that could be a human. For that, you need sensors, and for that, you need integrated sensors, because at the end, you might have a feeling that if the eyes are always in the same spot and not externally there, and also other sensors, when they all are integrated in one system, then it's much easier for this system to use this as efficient as possible. For example, to predict the environment. To help to understand the task to solve it, the robot needs to be able to predict the environment. If I look at my bottle, then the robot might want to think, I'm thirsty, and brings me something. If I have to say, well, I'm thirsty, please bring me this bottle, then already I've done it myself. So if I would think of some assistant or some assistive system that I always have to tell again in detail what I need, is not that helpful. And at the end, this robot needs to be affordable, because in industry, of course, it doesn't really matter too much. As long as you have return of invest, it's kind of fine. But we want to go in other markets: service, elderly care, rehab, household. In all these markets, it's very important if you have to decide between, do I want a robot or a car, robot or a house even, or do I want a robot or a coffee machine, or robot or e-bike maybe. That's quite a difference. Nowadays, a cobot, when you buy it, this is about 30%, as we say, of the total application, because you need external sensors, you need software, you need safety, and then if you change something, you might have to start again from the beginning. There are many integrators that use this to make money, because this work needs to be done every single time. But what you really need is a system that has this all included. Here we have a bubble around our MIRA that shows also human that detects, robot that detects human, has all the sensors included. So this one device thinking is what we want to show, because this is the point when you go from all these different boxes you grab into one device thinking that comes with some functions. You maybe have an example before. where this happens. We had Steve Jobs on there with a smartphone, and I will come back later on this. So if you have a robot that has senses, like a human, if with the senses the robot is able to understand the environment and then interact with the environment, this is the point where you come much closer to be really helpful in any situation of your life. For example, our Myra, which I'm not going to go too much in detail here. As Germans, we always want to do it faster, better, kleiner Spaltmaß, which I can't do in English, which we try. So the robot is fast, the robot is precise. I don't know, 6 micron, if you have a feeling what that is. It's a 1/10 of a human hair that you can go in repeatability here. But at the end, these are some functions that might be useful for some companies and might be not useful for others. But same as a smartphone, it has some functions that might be useful for you, some might be useful for others. At the end, what is most important is this one-device thinking. And here, of course, there's some people on the board, you know one, you probably don't know the other, but there are also some systems on the board. So we go from a landline phone to a mobile phone to a smartphone. And at the end, the smartphone is still a mobile phone, but the mobile phone is not a smartphone. And this is also how we see the difference between collaborative robots and cognitive robots. We use the robot as a platform so that everyone that really wants can provide some input using basic functions from our one-device thinking, that can use the sensors that are always on the same spot within the system, can use basic building blocks in our software, for example, our AI, and then write their own program. And then suddenly you can go in all markets that you want. Now there's some companies I look forward, for example, to Silicon Valley that say, okay, we have the greatest software, we might even have an app store, we might have a platform. But would the Apple App Store be as successful on an old Nokia 32 whatever? I don't think so. So it's very important that you have a good software, that you also have a good hardware, and then maybe other blocks like AI or so on. And this completely is what we try to advance to really get the technology. I'm not going to go in detail, but to really get the technology into our products. So all of these technologies are in-house technologies so that we can really tune them as much as we need, as much as we want to really get the product at the end that can profit from all of these. And there are a few products on the board, which later on you can ask me about or look on our website. I want to talk about AI especially, because all of these profit from our own AI, which is an AI that is locally on the system, because if you go to, I'm coming from Baden-Württemberg, Stuttgart, so if you go to like Daimler, Bosch, and these companies, and you say, hey, we have a nice AI that sends pictures and video, so super sensitive data to the cloud, usually you can go home. Yeah. It might make sense, and we do advance this cloud feature as well, but we need to be able to locally also work, because customers, at least in Germany nowadays, are not so happy about cloud. But on the other side, AI is very happy when they can work on cloud, because a robot that works with a robot is much better at collecting data. And if one robot for a year collects data, or 100 robots for a year collect data, that's quite a difference. And we have some solutions on this. We provide a local cloud as an example, but this is only part of the AI. You can interact with the AI, which we need, because at the end, everyone should be able to interact with the robot. You can speak with the robot, you can show the robot something, the same as a human would interact. You can guide the robot, but at the end, you can also code with the robot if you really prefer to. I have a few examples of AI, since I heard you guys are also a bit technical involved. Some features, for example, would be this here. Why do I show this? In Germany, we have lack of skilled workers, Fachkräftemangel. So I want, if I use a robot, I don't want to be the skilled worker that tells the robot what to do, and then the robot is the helping hand, so to say. I want the robot to be the expert. So in this case, with a partner from welding, we have taught the robot how to be an expert in welding. So the robot sees the product, sees how thick the metal is, for example, knows how to weld, what system of welding to use, how much power source, how much electricity, all these kind of things, how much speed and what kind of welding. And I, as I would to a welding expert, only use my finger, because this I have with me all the time, and show on the object, I want to weld from here to here. And then the robot does not look like a dog to my finger, but understands where I'm pointing to, and understands on the object where it needs to weld, and then everything else the robot does. That also means the next time I bring the same object and put it differently in the room, the robot still knows where to weld on this object because it understood on the object where to weld. Pick and place might be something that many here find very trivial, but gray of gray is something that at least experts from the industry know quite well. It's not so easy. Grabbing a random box with unknown objects and finding a way to solve them, or also, as you see in the moment, here just giving the robot a task. For example, this box now has to be moved somewhere else, and then the robot itself finds a solution how to do it. I don't have to hard code, okay, now move from here to here, then grab, then do something else. I tell the robot what to do, and itself finds a solution. Good example from automotive. I'm not going to say which OEM we have parts here, but the robot, as you can see, has two different grippers. A suction gripper and a two-finger gripper, and there's some objects in there. They're differently orientated. So usually this cannot be automized because some worker has to actually look at how the objects lie because they randomly are distributed. And here the robot itself looks at the object. If it finds a nice surface, it will use a suction gripper, and otherwise it will use the two-finger gripper. And I'll wait a bit longer. At the end, you see there's another problem. There's some plastic wrap and then some paper underneath. What do you do with that? Because you want to continue underneath. And this also the robot sees. Sees a nice surface, grabs the object, moves away. Sees another nice surface underneath, grabs the object, moves away. These are all examples where an autonomous system is much better at really solving tasks because it can think, and I don't have to think and find every solution beforehand because it could happen. The same for not only picking out of the box, but placing into the box. It's a bit small here, I think. I know it's fine. This video I want to show before, so I continue. People in the first row might see the company name on this. This is a project with a very big company. I'm not going to say it, but you can see for yourself. Here it is about placing stuff into a box. And again, here we were approached because of the robot that can think itself. So the AI will see how many objects do I need to place, what kind of object. This comes out of the system, and then finds the best way to place them into the box in the most efficient way. Other example, this I always show at the end because everyone is already annoyed for me showing too many videos, but this is another automotive OEM that needs to grab stuff out of the box. And the robot here sees how he grabbed something and sees also when he grabbed something wrong. So in this case, I was annoying and moved the piece a bit around. And the robot sees that and corrects at the end. So another example for robot thinking and not me that I have to think. That works one arm, that works two arm. Very important because at some point we also want to build our own robots, and for that we need more than just one hand. But there's more. I showed now a few features, but at the end, for a robot to be really helpful, as you might have seen before, the robot needs to be also strong enough. And this is always when I get asked, okay, what does that mean? In industry, okay, we can still say there's no one around, but when you go to service, household, and these kind of things, it's important. And so therefore, we also have sensors. The robot is able, on distance of 3 to 4 meters, safe. So that's when TÜV says diverse and redundant, privacy protecting, so there's no cameras involved. The robot is able, and I just show the video here, to detect a human and see there is a human. There's not any column or a wall, there's a human, and there I can react to. So that means if I come closer to the robot will be slower and stop at some point, or find a way around me. And then this also works, as you can see, when it's covered up. And then once it's safe again for the robot, it will start working again. So it doesn't matter at the end. AI, of course, will try its best to be nice to the human, let's say it like this, to be distant and to not hurt. But at the end, if the sensor says there's danger, the power is gone, and there's something all AI at the moment needs, and that's power to eat, to live, and so then it's cut. We have many projects like this. For example, here, it's an OEM system where we have our robots on a mobile platform. Because at the end, to be fully autonomous, you also need to be fully mobile. And this, of course, is for an industrial case. Quite similar industrial case, also looks quite different, is with an automotive OEM, because when you build cars that are electrically charged, to put the battery in the car, it needs to be empty. So at the end is the question, now the car comes from the conveyor belt, what do you do? It's empty. So someone needs to go and charge all these. This is something very easily done by a robot, as long as the robot is autonomously able to find the car, find the spot at the end where you charge, see how to open it, how to feel it, because what you need is a feeling. You can always try, I don't know if you manage, if you not look and not feel, try to plug in a USB cable. I can tell you it's quite hard. So you need the feeling of finding the right spot and then pushing in, or you need at least your eyes to see that. Yes, and then I teased it before. We can do this locally, but of course, AI should work together with AI. So what we do is try our best to find technology that on one hand, of course, robot can learn with robot together, but on the other hand, if you have a system with many robots and you plug in a new one, you don't want, like humans, we have to go to school 13 years. I took a bit longer, but different topic. You want to be plugged in and work right away. And this is very, very important and also very easy. That's why we want to centralize as much knowledge, as much brain as possible into our local cloud. Because at the end, when you have robots at some place, for example, here at the airport, you don't want this robot to do all the brain work by itself. You want some server somewhere that does all these things, and then you can have these small systems, for example, here, just very, very simply to follow you with the luggage, or to be in lab automation, where the main problem is you have all these expensive tools laying around, and then you have a test that, I don't know, takes 10 hours, 8 hours, and then you're done. Because at night, people need to sleep. Robots, not necessarily. So what this project is about is that the robot autonomously goes around day, night, 24/7, whatever you need, and recharges the testing stations and takes something out, puts something else in. There's many other applications. I just want to show at this point one more. I always put this on here because when I see this picture, I think, why would I need a robot to massage me? And I bet you, all of you, or nearly all of you, have the same thought. And why is that? Because for me personally, it's such a weird thought to have a robot massaging me. But at the end, if you think of it, technology-wise, the robot can feel very precisely. We can put ultrasound that knows exactly where you need to be massaged to feel well, or medically massaged. And then the robot will do this very well. Actually, in China, so I bring this example, I read this the other day. We have 1 million massage saloons, but we only have 250,000 educated massage therapists, educated or trained. So why is that? And suddenly you can understand, if I go to a massage salon and the probability is higher to get an untrained random massage than a trained massage, then suddenly it's much clearer that you trust on the technology. So when we bring one of our robots who do a massage actually to one of these massage salons and people know it's a robot, you will have a long line outside. So it's different feeling, maybe different culture, also different accessibility to technology. And if that's massage or breast cancer screening, which is the same technology, then suddenly the feeling is quite different. Should I be able, if I can't access a doctor, because there is not so many, to have no technology or have a robot that can do this maybe 90–95% for me? Then it's very clear. Then everyone will be, yeah, okay, I want to do this. But massage, since we find this as a pleasure, we suddenly have quite a different feeling to the technology. If it's massage, or if it's tic-tac-toe, or if it's chess. I put this on as a chess scene in a moment because the speaker after me, which I find very interesting, will talk about chess afterwards. At the end, these are technologies that when I talk to industrial partners, which are very often there, because nowadays in industry, the robot arm is very well accepted, and that's where we can make a lot of revenue, that's just fact. But I always bring these examples because where we really also want to go is not only industry, but I said it before, elderly care, service. There are many open markets that we have not been able to approach nowadays. And if we bring a mobile arm or maybe a platform that can do all of these things, then we have completely new possibilities. Our MIPA platform, which comes with one arm or two arm, by the way, these we bring as this platform thinking. So it will come with some basic functions. One of them, cleaning a room. One of them, swiping some tables. One of them, cleaning your dishwasher, which is currently a project we do with a very big, that you all know, company in Germany that builds dishwashers. There's many jobs in healthcare that are not filled at the moment, or filled badly, or not enough personnel for all these tasks. So there are already many opportunities for robots to take jobs without taking anyone's job. Might it be just moving some stuff around? Might it be bringing some water or some drink, some pills even? There are many jobs where they can just help already today, where not necessarily a doctor or a nurse needs to be present. And that's not only in elderly care, that's also many other situations where we have these. Supermarket, big example, many interesting opportunities. On one hand, at night, when everyone sleeps, we want to be able to autonomously fill the shelves. Don't need someone that gets up in the middle of the night. We don't need, of course, we can also have some autonomous system that just to some shelving system has some small supermarket. I bring this example because we have one where I live, where you don't need someone to stack the shelves. It just, you put some box in and it automatically moves there. So of course there's other systems, but with these autonomous features that you have, you can solve many problems where you don't have to be exactly, okay, if I want this shelf to fill, then you have to put a lot of boxes there. So you need to think of all these things beforehand. But if you have, again, an autonomous system, I'm for some reason always talking about automotive today, which is not what I want to. If you have an autonomous system that can think, so you give it the whole task, then when you sleep at night, it will think for you. Okay, there's some products, they lie usually here, I should bring them there. Hey, there's a box that is maybe broken or slightly edged or something, where a normal system would say, error, help me. Then I can think, okay, I can kind of detect this box, this should usually go here, so I put it there. Then this picture, I always love to have on for a long time. This, and this, and this. Why is that the case? Especially this one. Someone came to me the other day and said, well, that's all nice and good, but I don't want my parents to just be supervised by a robot. And then I'm asking, okay, if you bring your parents when they're old and cannot live alone anymore to some elderly care, who guarantees that someone really takes care of them? In an elderly care where they're maybe understaffed, worried about other things than talking to your parents. Maybe someone is dying or someone needs medical help, and then these things that are very nice or even things that are very hard to do. For example, people that has to lie down a lot, you need to rotate them and from one corner to the other corner once in a while. This is very often not done. How do I know this? We talk very much to these diaconese and also elderly cares that really want to use these because they say, yeah, we know many of these jobs are not done correctly, but what can we do? We don't find personnel to do that. Or the personnel we have doesn't like to do it, wants to do other things. And so then I say, Do you want your parents not to be taken care of? Or do you rather want a robot that takes away all the tasks others don't want to do, so that then the staff can take care of them by choice? By having the time to choose these things to be done, like talking to them. So maybe if I bring the robot doesn't have to talk, it can talk. But if the robot can do so many other things that the service personnel has time to talk to your parents, then why not? Maybe the robot is able to help a person so much that they can stay at home instead of going to the elderly care center. Yeah, maybe there's just a few small things that you need to have support, and instead you can keep living your life at home. So there are many options where this is important, and there's one more picture that I sometimes bring, and that is the robot or MIPA platform next to a child. And then always half the room says, "Wow, cool technology." The other half of the room says, "I don't want my kid to be educated by a robot." And then I say, that's fine. We can argue very much about should a kid always learn to clean their own room. Everyone has an opinion, and that's fine. Maybe, I don't know, 50 years ago it was about, or 100 years ago, should a kid learn how to milk a cow to be educated and learn something about life? So this perspective also changes a bit. But I really don't want to say every kid should have a robot to do the cleaning for it. I say if the robot can do tasks that I don't have to do, then I have the choice to decide myself what I want to do. And that's the difference. It's nice if the robot can clean, which it can. By the way, solves many marriage crises. Which job is it? Husband, wife, kid? We say the robot. But at the end, I don't care if you want to clean up your own room. I don't care if you want your kid to learn how to clean up your own room. But if the robot is able to do it, I can say by choice, I want to clean up the room because I find some weird pleasure in doing it. Should this be a humanoid doing it? I showed a platform before. I think many tasks can already be done by such a platform. But of course, nowadays, you see many other companies. I had one guy on the board that also showed their own humanoid. We, by the way, published one day earlier. Yes, of course, it makes sense. We, as humans, build the world in a way that we can use it best. Best and simple example, stairs. Why should a robot platform, or what should we do to a robot platform? Should it be able to fly with some turbines? I don't know. So at some point, having legs makes sense. Having a human skeleton makes sense, but not for all of these things. So when we show this platform, we specifically decided not to give it legs because it comes with many, many engineering problems that are fair to be tackled, but not ready today. And if someone shows a humanoid, also in media and so on, there's one guy in the US, as I said before, then the whole media presence says, wow, great what you did, but if I see such a product, and then like it does a bit of, you know what, then I see many good research institutions, also in Germany, who can do this since a while ago. Because at the end, there's a difference between having to show it once or having a product that works every time and can be sold. Because at the end, we are a company who want to sell products. We are not a research institute that just wants to show fancy stuff. So when I see these humanoid robots, then I also have to think of, okay, what kind of gears did they use? And what kind of actuators? And then at the end, I'm thinking, okay, but so listing this all, and then they should lift something or even lift themselves, not quite happening. So then it's very clear that there's many work to be done. And for example, now we could bring a few humanoids sitting here. I'm also nearly done this 5 hours was a joke, by the way. What I want to say is, yes, it makes sense, but does it make sense now? We want to solve many problems that we have, that humanity has, and that's why we have this MIPA platform. But at the same time, all the technology I've showed so far, and much more, robot arms, robot platform, AGVs, so autonomous systems, they all work to one step, and that is bringing a humanoid. By the way, this one is called For Anyone, because it should be for anyone. And to really be a platform for anyone, it needs to be usable, and that's not the case these days. That's where you spend a lot of work in these, combined with having products that we can sell nowadays. And of course, it's nice, have a skeleton, can do many things. Does it really need to do this thing? Not so sure. Does it really need to do this thing? Okay, now we can argue. Is it nicer for my parents to talk to a robot that looks like a human? Not so sure, honestly. We always also try to be quite abstract and very far away from actually looking like a human, because if it's too close, it's very easy to be a bit creepy. That's what we don't want. But do I need a humanoid robot to take care of my parents? Answer is, no, I do not. It might be nice that my mom can talk to something that looks like a human. I don't know. Everyone is different. Do we really need it? No. Do we need a humanoid in this situation? Again, maybe. Again, it would be maybe nice to have something that has a humanoid skeleton to take care of everything. But if I have a platform that can do all of these things today already, because all these things I said before is state of the art, then yeah, let's further develop these things so that at some time we can also have this, maybe rather for this actually than to clean at home. So we are from Metzingen. In Metzingen, everyone asked me, oh, this is where Hugo Boss is. Some newspaper a while ago wrote now, there's a new boss in town, so other topic. But so there is some situation where it makes sense to have a humanoid skeleton, and that's how I started this. Because we built the environment in a way that it's best for us. So when we talk about clothing, for example, yes, might make sense that humanoid, that for anyone, goes on catwalk, shows a few suits, a few clothing. Because there we're now in a scenario where we have something that needs to be human-like because it's for us. But that doesn't mean that to solve all these things at home, cleaning and so on, has to be done by something that looks like us. So let me show this.
Are you?
I don't know if I heard the sound. This is our CEO, by the way. He said, "Are you ready? So are you finished? Can I use you?" And for anyone said, "Are you?" So are we really ready? And this I find very interesting, because are we really ready? When we have nowadays a lot about ChatGPT and all these things, we have very speeded technology, new technology coming up. And then are we ready for a humanoid robot with a general AI, so an all-knowing AI? And I think not at the moment. We have to get there at some point. And when we are there, for anyone will be there. Because when we don't give AI a body, like this one, then we have other problems. Right now, when I think of AI, AI tells me what I should eat to not get more fat, what I should do to solve a problem. It can give me some knowledge. When I ask ChatGPT, it gives me some nice text or some information how I should handle things. So it's this entity flying around, I don't know, that tells us what to do. But I start at the beginning with it's all about time and it's all about getting the trash out. So does it really help me if the AI tells me to get the trash out? Because this I already get at home and it's a known problem. So I want to give the AI the body, so I can say to the AI, take the trash out, or do something else for me, and not the other way around. And I think this is the most important thing about, I started with technology and I want to end with technology. It's all about time, but it's all about time for us. And I want to have the time to decide ourselves when to take the trash out. Maybe at some time I'm too bored by not taking the trash out, I don't know. And then I want to do it because I want to do it. I don't want to do it because I have to do it. So if we really get the technology to this point, that it can help humanity everywhere and anytime, and then I can choose myself what I want to do. This is really the point where I think where we want to go with AI and where we will go with AI. And of course, at the end, it's very nice to talk about these things, products, nice robot arms, platforms, but I want to end with something else, because of course there's a nice team behind this, and there's just a few of them. Maybe some of us have visited our booth on Automatica last week. To make these things happen, it's all about time. It's also all about time that you have fun nowadays developing nice products. And so I'm very happy to be part of this team here at NEURA, and I think I see a few more happy faces, although these are only a few. We are 150 people now in Metzingen. So I, of course, with my last words, want to thank you for your time, but I want to spend the last moment of my presentation to really have NEURA Robotics give you a few more impressions of what we do. So I will end with this video, and then thank you for your time.
Yeah, thank you, Alexander, for this really nice talk. I think it's time to address some questions. Please just raise your hand. I'll bring the microphone.
So, taking up the "Are you ready?" question, so when will I have one in my home?
When you think you're ready, I can ask all the time. So this is something we get quite often, to get within a few years. I'll answer the question without answering the question by saying that for the MIPA platform, we showed last year a prototype, we showed this year again something. We'll go this year and next year to some partners, and then in 2-3 years, everyone will be able to buy one.
Are you predicting a price?
So the other day, when I looked at I think it was Saturn or MediaMarkt, I saw a coffee machine for about 5,000 euros, and I was like, is that why? So this will be the ballpark.
Thank you.
I will have a question too. Thank you for your presentation. And so I find it really fascinating how these robots are understanding the environment. And the caregiving part made me think. So I think that, when I bring my parents to a caregiving center or something, I want the people to take care of them, but even from a social interaction point of view. And you said that you are still taking distance from there. So do you foresee that there is potential in that part as well? So do you think that these cognitive robots can have a potential in that part as well? Or is that just something that shouldn't happen or wouldn't happen?
So maybe there's a misunderstanding. I did not mean to say we are taking a distance from social interaction. As a matter of fact, there's some project on this, because at the end, the most important point for robots to work in these places is acceptance. If the human does not accept the robot in any of these scenarios I showed you, then it's not happening. So there's projects on how can the robot move, not logically, but how it's expected by the human. There's project on how can the robot look acceptable, and that is, for example, not close enough to the human, but also not weird. And then there's projects on how would social interaction work. And for social interaction, that's a very important point. For industrial, I showed earlier, or in general for our robot arms, they are on the edge, so they're not connected to the internet. But in the moment we go to elderly care or household, suddenly this whole internet thing becomes quite different. So what we also need to take care of, how can we use the internet to help us with these things? And that means, also, for example, if you have an Alexa or a Siri, they can learn very well with all over the world, but at the end, they also only know a few specific commands. So if I have this Alexa and I give it to a friend, and I have one that really has no clue about IT and technology and whatever, that now wants to start a conversation with an Alexa, it's not happening. I can give it a few examples, and I think the reason why also Amazon now stops developing is because there's basically only 3 applications for it. What's the time, what's the weather, and play me a song of I don't know what. Yeah. So, but to really get social interaction, you need to go one step further and not have fixed commands that you can use, but really have the robot understand what you're talking about. And nowadays, you see, for example, ChatGPT, but not only, we get to this technology, but we need to use it as well.
So it's ongoing, and
yes,
because sorry for the second question, because still I find it kind of creepy in a sense. Mm-hmm. So will we get to a point in which it would be like if it was a human speaking? That's what I'm.
Do you want that it's a human speaking, or do you just want a platform that does what you need to do? So this is, I think, then at some point becomes an ethical question,
yeah, exactly.
Where we as a technology provider, of course, have to tackle at some point. I think at this time we're a step more at the beginning, where we first have to provide the platform as well, so the technology behind this.
Thank you very much.
We have another question coming from Slack. I'm over here. Yeah. But the question is actually from Slack,
yes.
From Rick. He says, you said that legs mainly are for aesthetic reasons there, right? To look like humans. Yeah. But how about walking stairs? So a household robot might need to walk stairs as well. Do you cover that as well?
Yes, so not only aesthetical reasons, but very often aesthetical reasons. Of course, there's many things such as stairs, and a few more things where we really need something light legs, or, I don't know, a rocket, to get up the stairs is one, and there's a few more, and that's why we're also working on this technology. I don't want to say that we're not working on this. I just want to say, of course, it might make sense to have a humanoid standing next to me, but many applications we think of nowadays, why we want such a platform, can also be solved without having legs. Of course, we're also working on that. Legs is a hard part of it, for sure. It's part of the technology, but that goes in this direction of, are we really ready, or is it really necessary today that my robot that wants to take care of either my parents or want to help me, I don't know, get a beer from the fridge, I need to walk stairs. Same question is, right now everyone at home has a vacuum cleaner robot. I would assume they also cannot, they can fall downstairs very well, at least mine, but they cannot go up. And this is certainly a solution we have to find. There are some different solutions, some wheel thingies, which I'm not going to go in detail, but legs for sure is also one of the solutions. So we need to get there, but it's not the solution for everything, legs. Yeah.
Thank you. Mine is, by the way, also an expert in falling downstairs, so I can relate to that.
Yeah, thank you also for the talk. Yeah, it's a great outlook. You showed this ecosystem of apps in the beginning, right, that we have on each smartphone platform. And what's the idea of how these robots or cognitive robots can learn new skills, capabilities? So are we also supposed to program something, or can we just talk and let them learn something new, like get out the trash, clean out this, and maybe do something new? How is that supposed to be?
So, very good question, and it's something, when you come to our labs, I will show you that if you talk to our Myra robot as an example, when you say, hey Myra, and then she asks basically what you want, and I say, pick this object, or pick any object, or do something else, when you look on when she understood and does it, you can look on the teach panel how she already coded her own program behind this. So this is already happening today. If you want the robot to program the program, it can do it. But at the same time, for this platform thinking, and then especially towards the MIPA platform, there will be an app store where everyone and also every company can write their own applications, because this is really how the platform becomes most powerful. If you think, if Apple would only use applications they wrote themselves, gone. Yeah? So the fact that everyone can bring their knowledge into the platform, knows that there are some basic functionalities and basic sensors, and so like on the smartphone, the camera is always somewhere, and then you have some other sensors. So having these functions, having this one device thinking, and then having everyone contribute to it, this is how it really gets powerful.
You talked about the applications, so it's here. You talked about the applications. Can you elaborate a little bit about the cognitive software behind?
What do you mean by elaborate? It's our own cognitive software?
Yeah, exactly. So to discuss the cognitive software, the capabilities and the principles behind.
Mm-hmm. So it's basically our own OS called Neuron OS, which is the basic software behind that first. So this is basically basic functions, and then we have, for example, the AI as our internal customer, but also others access the software via APIs. So we have some basic functions, basically Lego blocks that we provide that can do certain things, and then it's up to the customer or the integrator to build a tower or build an application out of this. Is this go this in the right direction? Okay.
Hello. You mentioned in a part of the presentation about an unrealistic robot that has, it's a humanoid and it does everything that a human can do, but we're not there yet. And recently I came across like a small pet robot that basically has wheels, and it just follows you around and answers your question. So it's an Alexa on wheels. Mm-hmm. Between these two, how far along are we to this unrealistic or the robot of the future? And a follow-up question is, will the robot of the future look closer to a human, or will we adapt the environment so that it's better, that we don't need stairs, we do an environment that fits to the robot and not the other way around?
I think since humans are humans, it will always look like a human, because we will always have the environment in a way that helps us. But then, of course, you can think, okay, we have stairs at home, and then when we get older, maybe we move to a home that does not have stairs. So in some way, maybe a balance out of both, but I think at the end it will still look like a human, but abstract enough to still look like technology as well. At least, talking about myself, I'm fine having it for anyone at home. The other day I saw a project where they have a human realistic face with all the stuff belongs to it, and then when I think of walking towards that, maybe then the acceptance between me and the robot is, maybe others are different. For me, that would be still a bit off what I want. So at the end, in my opinion, it will still look like technology, but have the advantages of human skeleton, for sure. And then the other question was, are we, I don't know, now the microphone is gone. You talked about something on wheels going behind me. Actually, I saw a video once where some jukebox just followed around, or like some alarm device that just runs away, is the other way around. I think we are at a point where many of the things that we think are too far away are actually state-of-the-art. Very often when I talk to potential customers that comes for us for some very basic solution everyone can do, and then we talk about what is cognition, what is this platform, then the thought process is like, wow, I didn't know that's possible. Then I have also an option where I could do this. So I don't think we as society are aware what is possible. And a reason for that I also think is when I now look at different AI technology that comes to the market, comes fast to the market, where many people are like, oh my God, what is happening? Are rather afraid than ambitious to try it. I always say, I think we, and also we as Germany, that are certainly still, in comparison to Silicon Valley or also Asia, quite well, especially on the hardware side and technology. If we as a society find a way to approach technology rather than only see the dangerous side, of course, we have to discuss also the dangerous sides of AI, and there are many. If we approach it, then we are much easier to the point where we can say, okay, it's interesting, I didn't know that it's possible, it's quite helpful for us as well.
I'm curious, again, about the integration of different capabilities. Like the version you want to offer to consumers, is that supposed, like the $5,000 coffee machine, it's not supposed to do only coffee? Like, what is that version supposed to do? And if you outsource adding additional capabilities to like apps or external developers, how do you like want to guarantee reliability? Like, again, looking at Amazon Alexa, there are skills and they just don't work quite often. Like, how do you make sure that people get the robot and it's actually working if you outsource that?
Yes, so most important point before it's working or not is it safe or not, I think, especially in the interaction with human. And there we have technology that takes care of that. Some sensors that don't care about AI or other things, when they see a dangerous situation, they will stop the system. And then when you talk about if it's working or not, then of course, we ask us the same questions that also Apple and also other, I mean, there's many platforms on the market ask. There needs to be some kind of quality control. In combination with some guidelines how to use it. And this is something we are at the moment implementing. Basic functions, as you asked, are, for example, I was not kidding earlier, cleaning up the room, emptying the dishwasher as a project. It's actually a public project, so you can look up which company it is, but I mean, it starts with M, and many have a dishwasher at home. And then some interaction modules for sure will be available, and then people themselves are able to choose, am I happy with the basic functions? And then I don't even need internet. I don't need to send my data somewhere. I can just buy the product as I wish. Or do I want more? And I think at home, everyone is much easier on data than industry, for example. So people will very often say, okay, I want more. I want the connection to the cloud. And then I have the connection to the App Store, where applications will appear. I expect many from also companies that make the product then easier to use there. So for example, when I have a fridge at home, a very specific fridge, I'm not going to say any brands, and I want to grab water or beer or something. And then the company who builds the fridge is of course interested that our MIPA platform can use their fridges especially well. And then they write an application that they sell, that they make money on our platform, and we do too. And then, of course, you need to find automatic routines, but also probably manpower behind that finds a way to guarantee that not only safe, but also usable. Yeah, so this is an ongoing process to answer short after talking long.
Yeah, right. I think that's been plenty of questions. Looking at the time, I think it's a good place to cut it. Yeah, thank you, Alexander, and let's thank him again.
Thank you.